All right, welcome to 1.1, day 1. We are going to do your problem of the day. Problem of the day is, what is 9 squared? 9 squared looks like this, 9 squared. 9 squared just means 9 times 9. And 9 times 9 is 81. That's your final answer. So 9 squared equals 81. All right. Now, take some time to yourself and do this problem on your own. Pause right here, and when you're done, resume to see if you got it correct. Good luck. All right. So 5 squared, you should have put 5 squared equals 5 times 5. And 5 times 5 gets you 25. Hopefully you got that correct. This is your problem of the day, and let's move on to what you're learning today. Today you're going to be doing representing rational numbers as decimals. Here's your steps. You're first going to set up the problem, then you're going to divide, then you're going to subtract, and then you're going to repeat those as you needed. Here's some vocab for you. Rational numbers, any number that could be written as a ratio, A over B. Ratio is a fancy word for fraction. So we're going to be writing numbers as fractions we're going to be writing fractions as decimals today. Then you're going to be hearing about two different things. You're going to be hearing about terminating decimals and repeating decimals. These two, so terminating decimal, we like to refer to the terminator, which stops everything, stops bad guys. So these decimals stop. Repeating decimals mean what they say they mean. They just keep repeating forever and ever and ever and ever. Uh-oh. Don't want that. Uh-oh. Now I have closed captions at the bottom. Great. Okay. Here we go. Moving on. And I still need to be able to get my pen back somehow. There. Okay, here is my example. So we like to say top dog goes in the house. So here is my division house. 1 goes on the inside. Then we are going to do 4 on the outside. All right, now we got to divide. Can 4 go into 1? No, so we have to put a decimal and make sure that decimal floats up to the top. Then I'm at a 0. 4 can go into 10 2 times. 2 times 4 is 8. If I did 4 times 3, that gets me 12, and that's too big, so we have to make sure we stay under, but just close enough. Okay, so 10 minus 8 is 2. And now 4 cannot go into 2, so I have to add another 0, bring that down. 4 can go into 20, though, perfectly. 4 times 20, 4 times 5 gets us 20. And that will get us 20. And subtract, we get 0. Once you hit 0, we are done. So we got 0.25 as a final answer. That should look familiar to you because that looks like 25 cents. And there are 4 quarters in $1, but we only have 1 quarter. So that means we only have 1/4 of $1. Oh, cool. They put fractions in what I'm saying. Interesting. All right. We practice this one together in class. So there is this 3 here. Leave that 3 alone for now, but it will come back at the end. So we're going to deal with the 1/8. So top dog goes in the house. So 1 goes in the house. 8 goes on the outside. 8 cannot go into 1, so I have to add a decimal, bring them up to the top. 8 can go into 10, though, and it can only go once. 1 times 8 gets us 8. When I subtract, I get a 2. Then we have to bring down a 0. 8 goes into 20 2 times. 2 times 8 gets us 16. Then I'm going to subtract. 20 minus 16 gets us 4. And last but not least, I have one more 0, I believe. 8 goes into 40 how many times? 5 times. 5 times 8 gets us 40. And when you subtract, you get 0. So that means I'm done. Now, we're not done, though. Our decimal is 0.125, but we're missing something. We are missing that 3. That 3 is going to get put in the 1's place on that side of the decimal. And so we got 3.125 as a final answer. Uh-oh. There we go. Okay, now we're going to do an example of a repeating decimal. So same rules apply. Top dog goes in the house, so 1 is still going to go on the inside. 6 is still going to go on the outside. 6 cannot go into 1, so I have to add a decimal place. Then we add a 0. 6 can go into 10 once, because 6 times 2 is 12, and that's too high. So 1 times 6 gets us 6, and we are going to subtract. 10 minus 6 gets me 4. So let's add a 0, bring them down, because 6 can't go into 4. So 6 times what gets me 40? Well, 6 times 6 gets me 36. 6 times 7 is 42, and that's too high, so I'm going to do 6 times 6 gets me 36. Subtract gets me 4. Uh-oh. What happened? Anyone see what happened? There's a 4 here, and look, I just got another 4. So what do you think is going to happen? That's telling me that that 6 is going to keep repeating the entire time. So we can stop there, work smarter, not harder, and just that we're going to put a repeating bar over that 6, and that tells us that 6 is going to keep going on forever and ever and ever. This is our final answer. Okay, we're going to do, one more. We also did this one together. So again, we have a whole number of 2 on the outside. Leave that alone for now. That'll come back later. We're going to focus on that 2/3. So top dog goes in the house. So 2 goes inside. 3 goes on the outside. 3 cannot go into 2, so we have to add decimals and a 0. 3 goes into 20. Well, 3 times 5 is 15. 3 times 6 is 18. And 3 times 7 is 21. So that's too high. So we're going to do 6. 6 times 3 gets us 18. We subtract and we get 2. Uh-oh. Didn't we start with 2? Wasn't that what we just did? We got 2 here, and we just got another 2. What's going to happen? That 6 is going to keep repeating. So we are going to have to put a repeating bar over 6. And don't forget what else we need. That's right, we need that 2. So it's going to be 2.6 with a repeating bar. And that is both repeating and non-repeating or terminating decimals. Please let me know if you have any questions.